Hello everyone. So this is a question from JEE Mains 2026, 28 Jan, Shift 1. 500 ml of 1.2 molar Ki solution is mixed with 500 ml of 0.2 molar KMnO4 solution in basic medium. Okay. Liberated iodine was titrated with standard 0.1 molar Na2S2O3 solution in the presence of starch indicator till the blue color disappeared. Okay. The volume in liters of Na2S2O3 consumed is, okay, so the nearest integer. The chapters involved is redox reactions. Okay, so according to the law of chemical equivalence, gram equivalence of each of the reactants is equal to the gram equivalence of each of the products. Okay, that is, for a reaction, let's say, that is not balanced, A plus B giving me C plus D. So according to the law of chemical equivalence, I can write gram equivalence of A is equal to gram equivalence of B is equal to gram equivalence of C, which is equal to gram equivalence of D. Okay, this is very helpful because we don't need the balanced equation to apply this law. So to calculate the gram equivalence of any substance, we know that normality is equal to gram equivalence of solute divided by volume of solution in liters. Okay, so therefore we can write gram equivalence of solute is equal to normality into volume of the solution in liters. Okay, and we also know that normality is equal to n factor into molarity. Okay, so therefore I can write gram equivalence of solute as gram equivalence of solute will be equal to n factor into molarity into volume. So this is the formula that we are going to use. Okay, and to calculate the n factor of an oxidizing or a reducing agent, we use the formula n factor is equal to modulus of final oxidation state minus initial oxidation state into number of atoms changing their oxidation state. Okay, so using these prerequisites, now we can solve our question. Given that 500 ml of 0.2 molar MnO4 minus in basic medium is mixed with 500 ml of 1.2 molar Ki solution. Okay, so MnO4 minus in basic medium gets reduced to MnO2. Important, MnO4 minus in basic medium gets converted into MnO2. So therefore, with respect to reactions, I can write MnO4 minus plus I minus will give me I2, obviously, plus MnO2. Okay, so no need to balance this. So let's calculate the gram equivalence of MnO4 minus and I minus using the formula, this formula that we are going to use. Okay, so for MnO4 minus, which is changing to MnO2, so the oxidation state of Mn will be x plus 4 into minus 2 will be equal to minus 1. So x is going to be plus 7. Here x plus 2 into minus 2 will be equal to 0. So x is going to be 4. Okay, so therefore the n factor will be equal to modulus of final oxidation state 4 minus initial is 7 into 1 Mn is undergoing change 1. So this will be equal to 3. So therefore the gram equivalence of MnO4 minus will be equal to n factor, which is 3 into molarity is 0.2 and volume is 500 ml, so 500 by 1000, so this will give us 0.3. Okay, for I minus, we can see it is changing from I minus to I2. Okay, so I minus is changing to I2. So the oxidation state of I here is minus 1 and I here is 0 because oxidation state of atoms in elementary state is 0. Okay, so therefore n factor will be equal to modulus of final oxidation state 0 minus initial oxidation state into 1 iodine atom is undergoing change 1, so it will be equal to 1. Therefore gram equivalence of I minus will be equal to n factor 1 into molarity 1.2 into volume of the solution 500 ml. So 500 by 1000. So this will give me 0.6. Okay. So I will write down the reaction again. So the reaction was MnO4 minus plus I minus, giving me I2 plus MnO2. Okay. So the gram equivalent of MnO4 minus that we calculated is 0.3. Gram equivalence of I minus is 0.6. Okay. So you can see here that 0.3 gram equivalent of MnO4 minus will react with 0.6 gram equivalent of I minus to give 0.3 gram equivalent of I2, because MnO4 minus has lesser gram equivalents. So therefore this is the limiting reagent. Okay. And zero point 0.3 of MnO4 minus needs zero point 0.3 of I minus. So therefore 0.6 minus zero point 0.3, that is 0.3 of I minus, will be left unreacted. Okay. So therefore I will repeat all the gram equivalents. Here we have MnO4 minus 0.3. Here we have 0.6. Out of this 0.6, 0.3 will react with MnO4 minus to give me 0.3 I2, and 0.6 minus 0.3, that is 0.3 gram equivalents of I minus, will be left unreacted. Okay. Therefore, I can write that 0.3 gram equivalent of I2 is formed. Okay. Then this 0.3 gram equivalent of I2 is titrated with 0.1 molar Na2S2O3 solution, which is the thiosulfate solution, in presence of starch as an indicator till the endpoint. Okay. With respect to reaction, we have to know that thiosulfate ion, that is thiosulfate S2O3 2 minus, changes to tetrathionate. Tetrathionate is S4O6 2 minus. Okay. So with respect to reaction, I can write I2 reacts with S2O3 2 minus to give me I minus plus S4O6 2 minus. Okay. So at the end point, all of iodine, that is I2, has combined with S2O3 2 minus. So therefore, at the end point, I can write gram equivalent of I2 will be equal to gram equivalent of S2O3 2 minus. Okay. So we know the gram equivalent of I2, right? We have already calculated it is 0.3. So let's calculate the gram equivalent of S2O3 2 minus. Okay. And it is changing to S4O6 minus 2. So let's calculate the oxidation state of sulfur here. It will be 2x plus 3 into minus 2 will be equal to minus 2. So 2x will be equal to 4 and x will be equal to 2. Here 4x plus 6 into minus 2 will be equal to minus 2. So 4x will be equal to 10 and x will be equal to 10 by 4, which is 2.5. Okay. So therefore n factor will be equal to modulus of 2.5 minus 2 into, you can see two atoms of sulfur are undergoing change. Okay. There are two S atoms in the reactant. So therefore it will be my into 2. Okay. So this is 1. So therefore the gram equivalents of S2O3 2 minus will be equal to, n factor is 1, molarity is 0.1, and volume we don't know. So let's say it is x liter, and this is equal to the number of gram equivalents of I2, which is 0.3. So upon calculation, I will get x as 3 liters. Okay. So therefore, the volume in liters of Na2S2O3 consumed is 3 liters. Okay. Thank you.